Hey, my name is Max, and every week I'm reading from this 2025 AI Engineer reading list. This is week 3, and in my last video I talked about Meta's Llama series of papers, and today I'm going to be talking about Mistral's Mistral papers. Mistral AI is the first non-American AI company I've looked at, and they're actually based in France, and they prioritize making small, efficient models that are open source. And so the first paper of them that I looked at was Mistral 7B, a small 7 billion parameter model. And this one actually outperformed Llama 2's 70 billion parameter model. And to do this, they did two things. The first thing they did was grouped query attention, which is a way to improve efficiency without sacrificing performance by grouping certain queries together. You can look at this graph for a quick little overview. Their other improvement was implementing a sliding window attention with a rolling buffer cache. So you can see some diagrams here kind of showing architecturally how that works. But in short, instead of looking at the full token context, you're only looking at the past, W in this case, 4 number of tokens in your window. Overall, this paper was really condensed, only 9 pages, and my favorite to read so far. And their second paper kept up with this. This was their sparse mixture of experts paper called 8 by 7 billion or 8x7b. And here they pretty much unveiled the mixture of experts architecture, where you basically have 8 versions of the 7 billion parameter model, but each one is trained or learns a little bit of different information, so it's an expert in a different thing. And then you have a router that picks 2 of those at a time to run an inference. So even though you have access to, in this case, 47 billion parameters, you're only picking and running 13 billion of them. The last Mistral paper I looked at was the Pixtral 12B model, and this was their first multimodal model. Tongue twister, try and say that fast. And here they actually trained their own vision encoder from scratch, which allowed it to take in images at their natural resolution, as opposed to some other approaches that would restrict it to a predefined restriction. And for performance, this at 12 billion parameters actually outperformed Llama 3.2 at 90 billion parameters, which is pretty crazy. So overall, I really liked these papers. And next week, I'll be taking a look at DeepSeek. So I'm really excited for those. I'll see you guys next week.